Okay. Um, Good morning, ladies and gentlemen. I see Bhavani only. So, good morning, everybody. So, my name is Kurmi, and I am the makeshift host for this webinar, number 7. Um, and I would like to welcome Prem to this community for sharing your knowledge. Welcome, Prem. Mm, Thank you so much for agreeing to be part of this webinar. So this is webinar number 7, and I will let you know what happened with our face-to-face plan, a face-to-face conference plan, which was supposed to be in August as we move along. So for the interest of people who are joining us for the first time, Smart Testing Community is a non-profit community of 120 plus members. So we have grown from November 2017 when a few members got together to start this community of interest. These 120 plus members come from 40 different organizations in the city. Some of them are big, some of them are small in terms of size of the organization, but that has not prevented people from differentiating the knowledge sharing capabilities within the community. Till now we have had 6 webinars and 1 face-to-face conference, which was in April 2018. The intention for this community is to learn through collaboration, share ideas, share best practices, share opportunities in terms of having collaborative workspace, doing research together, so that the community grows by learning. It's a non-profit organization, like I said, so there's no money involved here. Like Krishna loves to say, the money is in the form of learning, and that is what we earn, that is what we gain, and that is what we share or contribute back to the society. So that's where the intention of this community is. Now, for people who have joined newly or for the first time, it's a smart testing community, and I'm sure you would have gone through some of the documentation associated with the formation of the community. So SMART, S stands for search, M for monitor, A for analyze, the other A is the automate, R is the research, and T for tracking. So these are the first few words of the community definition. So I request you to look up to LinkedIn LinkedIn for this community, where you would know what we stand for and what those acronyms actually means in our life as the community members. So how do we connect? Primarily social media is our interface with each other and also with the rest of the world. We do intend to have monthly webinars, and the intention is to have it on the first of the Saturday. And all the webinars till now have been recorded and are available in our YouTube channel. So this is one webinar which is not happening on the first Saturday of a month, and originally, we had a plan to have our second face-to-face conference in August on 4th, but due to some logistic challenges, we landed ourselves in missing the second face-to-face conference. So we are now in the webinar number 7 in August, and we hope that in the near future, as per our original plan, one face-to-face conference in either 3 or 4 months of a year. So we would look forward to having the second face-to-face. So for a face-to-face conference, we look for logistics support in terms of a conference room, in terms of permission from the organization who is willing to sponsor, and then a place for about 50 people being able to sit down for 2 to 2.5 hours, and then collaborate. The first one was sponsored by Micro Focus, and they were kind enough to extend some other logistics supports, including tea, coffee, a space on a Saturday, and other hospitality. So in future, if anybody is willing to sponsor, or anybody's organization is willing to sponsor, we would love to hear that, and make sure that we leverage that experience in the next face-to-face conference. Next slide. So the idea for this community is collaboration, learning through collaboration, like I have mentioned and like you've known from the past. How do we ideate is a perspective. So normally ideas could be generated through some research that you're doing in your own work, or you could post you were driving down the highway to your work. When I say highway to your work, it may be a 5-kilometer drive, but it might take you 1 hour in Bangalore. But during the time when you're standing in the signal, you might just have some idea flash your mind. And do not hesitate to share that in the community. I'm sure it will click in somebody's head, and then 2 becomes 4, 4 becomes 8, and it might just multiply into a great research or conversation topic in the theme that you're interested in. And in the past, what we have done is we have requested for ideas, and till now that's how the webinars and the conference have happened, have continued to happen. And in the future also we intend and plan to do the same. The ideas for the next webinar should definitely come from the community, where it can generate more interest, participation, and so that we can take this community further into a significant one, not only in India, Bangalore, it should be also in India and worldwide. So I like the tag. Right now we've listed that we are world #1 community. Okay, we want to be recognized there. The last one in my list for welcoming ideas is to get more people. The larger the community, more is the ideas, and better is this for the civilization. The more and more ideas, the sense of appreciation for those ideas becomes better with larger community and with larger participation. So please request you to get your colleagues or your friends who are interested in the domain in this area of specialization, and so that they can add value to this community. Next slide. With this, I would like to introduce our speaker, Prem Sankar Gopannan. He's going to talk about artificial intelligence in testing. This is one of my passionate subjects. I've been doing a lot of reading in this. Thank you, Prem, for accepting our invitation and helping us with sharing your knowledge. So Prem works as a Director of Engineering at Lumina Networks and manages product development team, focusing on next-gen telecommunication and networking products. Before this, he was part of Ericsson Cloud CTO's office, and he is a regular speaker in industry forums and have many presentations on the technologies that are listed here on your slide. So looking forward to a very enriching and a learning experience, Prem, and I hope that the weather today is kind enough with us. Beautiful cold weather at 20 degrees in Bangalore. It's an awesome experience to sit back and relax and learn from what Prem has to share for us. Over to you, Prem.
Thanks, Kurmi, and hello all. It's great that you're joining in on a Saturday morning. So it's kind enough of Krishnan to probably invite me to this forum. I'm excited to be part of this forum and looking forward to contribute more. So with that, let me get into the topic. So even though it is a heavyweight topic, make it light. Um, so I'm going to talk in simple terms as against using any major jargons. Uh, so please bear with me in case if something goes out of context or it becomes a bit complex. So okay, so with that, let me get into the topic. AI ML is of course an hot topic, be it in Bay Area or be it in Bangalore. Most of the companies they look to invest. Uh, they are looking to invest a lot of money around this because this is the future, as for many of the companies. So I think Krishnan asked if they're able to see the screen. Let me know if you're able to see my screen.
Yes, we are.
Okay, sure. So now, rather than jumping into the hype, why do we need to really look at AI from an SQA perspective? Let's probably analyze the current trends and software architectures, and then let's evaluate whether we really need AI or not. So as we speak, so you have software architectures evolving and they're becoming more complex. I understand from Krishnan that you already had a session on microservice architecture, and microservice architecture is one of the key enabler of the disruption, be it the container or be it the Kubernetes. Both are really revolutionizing the whole software community as well as the product community. Now, what is it? Where are we heading towards the question? So I used to evangelize. Yeah, sorry.
Hi, Prem.
Yeah.
There's a request to increase the volume. Is it, if it is possible?
Sure. Let me try to do that. How about now? Is it?
Yes, much better.
Okay. Sure. Thanks. Yeah. Yeah. So continuing. So the reason for the evolution of Microsoft architecture is twofold. One is the business need. Another one is the evolution in the software or the enablers like cloud computing, right? So when in fact, I used to do a lot of evangelization around cloud computing, and it used to be very, very difficult for me to talk about or talk about new architectures, right? Because if you look at conventionally, most of us have probably more than a decade or more of software development experience, right? And we have mostly dealt with products, right? So even from a testing perspective, when we take a product, we first look at whether we are meeting the hardware requirements as mentioned in that of the manuals or the user guide, right? And even the software developers, they are bound to develop their software based on the reference hardware that is recommended by the product management team or people who basically recommend it, right? Be it the customers, right? Now, here comes cloud, wherein we have unlimited hardware, unlimited network, compute, storage, and has our software evolve in order to exploit this question, right? So what is meant by evolution? Let's probably look into it, right? When I say evolution, let's assume that I have a software and then I want to probably put it into the customer scenario, and the customer, let's assume he wants to scale his software, right? How do we scale it, right? The simpler mechanism is basically to put a load balancer in front of the you have a bunch of software and then put a load balancer and then try to load balance. That's one model, right? But at the end of the day, let's assume the customer users say 40% or 50% of the product you have developed or delivered, right? And the remaining 50% he does not use, right? Do we give them enough knobs to tune or tune out those 50% of the product? May not be, right? Because most of them are essentially designed to be sold to a majority of the customers, and what we do as in terms of deployment is nothing but just put the configuration parameters suiting to that of the customer needs, right? That's what we do. We don't really open up the software or disable modules, right? Even if you disable the resources on or continue be consumed, right? Now here comes the microservice architecture wherein you can compose. What I mean by compose is, let's assume for a reference or use case, let's assume you have a router, okay? Let's assume the router has three major modules, right? Routing plane, data plane, and then routing protocols, right? Some of the major routing protocols are like, say, OSPF, REP, BGP, right? Now, what I want is, I'm deploying to the customer. So, say for example, the site A or a customer A, they would just have they use extensively the RIP protocol, and then they want 5 instances of RIP, right? And with microservice architecture, you can basically pick and choose and then configure your own software or your product based on the deployment scenario. Okay, so that is what we call as the composable systems. When I say composable systems, you compose the whole product based on the deployment scenario, right? Now, with that, let's touch upon cloud native. Now, I have cloud native. When I say cloud native, I am able to scale, which means I need to be able to scale depending upon the geography. Say, for example, I have 5 sites all across the globe, and then I want to basically have communication between them, between the sub-modules. Is it possible? Yes, there are architectures that are evolving to enable that, right? And the third one is about intent-based systems. What is meant by intent-based system is, since these architectures are inherently composable, I need to have a fine-grained policy which would essentially drive what is the intent so that the relationship is set up. And second thing is, am I allowed to have this intent defined? If so, what are the privileges? For example, let's assume a billing module wants to talk to, or a UI or a web module wants to talk to database. Is it allowed? May not be possible, which means the intent, even though there is an intent, it would be protected because of the policy that is defined by the system, right? So essentially, when I say intent-based systems, you tell what is the intent, and then you go through the policy definition system, and then it gets composed based on the intent, right? And then the last one is immutable architecture. There are a lot of developments. The one is basically what we call as the edge cloud scenario, or the 5G, which is the next generation of telco products. So there, what happens is you have multiple sites which may sit next to the customer or next to that of a radio base station, and then what happens is the software you push to this particular scenarios or to this particular sites are basically immutable, which means you cannot change or upgrade any of those software. You just push it. If you want to upgrade, pull it out and put a new version of it, right? So now you can understand how the software architectures are becoming complex. To further complicate it, you do have deployment models which are quite becoming dynamic, right? Which means my CI/CD can start generating software, and then probably the system would essentially make me to deploy directly just to do alpha testing or so, right? And also, you might have been familiar with new model of testing, which is called A/B testing and canary testing. What it means is, with the ability of the microservice architecture, you can basically now take bunch of microservices that are present in your development environment, which are under development, but you want to basically test it as in the real scenario, right? How do you do it is, you do have intelligent proxy systems, they call it a reverse proxy, where you can essentially set up a policy which says that, hey, send probably like 99% of the traffic via the production network, and then send the remaining, say, if it's 1% to that of the test network, right? And then the system does it, which means in the same deployment environment, you have both software which are production ready, and you have software modules which are not tested, or which are just tested with a minimal with a minimal test cycle, right? Now, I mean, these are some of the most complex system I have explained, right? With that, let me just give a quick snapshot of what are or how the cloud native ecosystem looks like. So this is the cloud native landscape. Believe it or not, there are already companies who are using it extensively, and these are some of the tools which will help you to enable realize your product based on cloud native architecture. Right now, just the landscape itself may look a bit scary, right? Because with open source momentum gaining a lot of traction, more and more people are coming out with their own architectures, which means you see that in a single subset of the landscape, you see, for example, say observability analysis, you see Prometheus, you see a lot of new software tools, but these tools are essentially the same type of tools, but from different companies, right? Now, we are bound to use these systems because they are already developed, they were tested in production, and then now you can start using it afresh, right? Now, if I want to consume and if I want to realize my new product architecture, the question that comes to everyone's mind is, can the following listed testing methodologies be able to meet the needs of such architecture, right? Take for simple example, you have the canary testing scenario. Let's assume that you have issues coming out of it. How am I going to debug? Because the software is new, I have not tested it, I don't know how it behaves, and I don't even know how to interpret the test results that come in from the deployments, right? So that is where we probably need to look at how can we leverage AI or machine learning so that we can inherently test or make our testing methodologies much more smarter, so that when you integrate it with your CI/CD system, the end result is essentially a near well-tested software, right? Does it make sense? So I'll probably pause for a moment here and then take up any questions before I move on to the next section, which is essentially getting into machine learning. Any questions? Probably you can type it in the chat window.
Prem, this is Krishna. You able to hear me?
Yes.
Maybe this question is maybe later or something like that. But the AI-based testing, how much of traction is gaining in the industry? I mean, I think those are your current slides that you present. Just curious.
Well, so let me tell you something. So this is actually from the. Okay, so let me tell you. So this is basically from Linux Foundation. So Linux Foundation is basically an organization that hosts many of this open source software, and what they do is they basically qualify this software so that they go through a graduation process and then people can pick it, right? To quote an example of some of the well-known tools that are being used, one is Kubernetes. I believe everyone knows what Kubernetes is and how it has gained popularity. Next is, for example, gRPC. Then you have MATS, which is essentially a major messaging framework. But to put it in simple terms, there are many enterprises which have already started adopting this, right? So what's happening here is gone are the days where people wait for products to be coming in from vendor companies with proof that it has been tested extensively with features that they may have requested from 6 months back, but now they are seeing that they can realize that some of the software as well as some of the feature sets are quite rich. They start using it immediately without waiting to have any approval or without getting any consent. So that's the disruption, I would say, or the mindset change that has happened in the enterprise world. At least this is happening at least in the US. And how do we get the feedback is basically the customers, they come and attend the conferences and share their feedback on how these systems are. That's how we get the feedback on how the systems are being used. Did it answer the question, Krishna?
Yeah, that's fine.
Okay. So now let's move on to machine learning. So before moving on to machine learning, let's quickly understand why is machine learning gaining so much of traction, right? So machine learning is not a new topic, right? At least it has been there as a research area for the past 30 to 40 years, right? Even some of the algorithms or categories have been there for long, right? But why is that it is gaining now is because of the tools, because of the infrastructure. When I say infrastructure, let's assume that if you want to realize machine learning, if you want to run through different cycles, you would probably need a parallel computer, say 5 years back, right? And how many companies or how many people have HPC computers or parallel computers? Very few, right? And then you need a lot of investment. But now, be it Azure, be it Amazon, or be it Google, they do have cloud which are GPU enabled. And by the way, GPUs are primarily used for running the machine learning algorithms. That is one. So this is from the hardware infrastructure perspective, right? The second thing is also the ability to store the data, the ability to get the data, I would say modified or transformed to that of what I need is the second requirement, right? Again, you have ETL tools as well as other tools that are available, which would essentially help you to do it. I'm talking about even open source tools. The third one is the machine learning algorithms themselves. Gone are the days where you have to write the machine learning algorithms. You have readily available libraries, be it in Python or be it in languages like Java, where you can just feed the data set and then you will essentially get the output for based on the data set, whatever you fit to the algorithm, right? So the most important thing, or the most important enable for all of it is essentially the availability and the abundant availability of tools at a much more lower cost, right? So that's the most important thing, right? So second thing is also the industry has evolved so much that they come as packaged deals. When I say packaged deals, for example, you need a system to store the data. You need a system to do your machine learning testing. You need a system to verify the results. You need a system to give back the models or store the models, right? And get them as we go, right? So for that, you do have a lot of machine learning, I would say, at a framework that is available again in Google Cloud, Microsoft Azure, and Amazon, right? Now, with that, just to get into a bit of basics of machine learning, I believe for some of you it might be a repeat. So typically, machine learning is all about it comes under the artificial intelligence, wherein what we make is we make the machine learn and then interpret and then automate certain things and also infer or suggest. So you use it for many things. For example, it's a thin word between data analytics and then machine learning when we began the journey, right? Because you talk about advanced analytics like predictive analytics and prescriptive analytics, which in a way loosely falls under machine learning, right? So the idea here is essentially make the machine behave like a human, so that you can, to begin with, you can give the system a repetitive task and then take actions based on those repetitive tasks, and make it further intelligent so that it can automatically learn and do things as the scenario or data set changes, right? Now, there are three broad categories. One is the supervised learning, the second one is unsupervised learning, the third one is reinforcement learning. The supervised learning is pretty much a straightforward thing, wherein you do have the main goal is essentially to predict, given a data set, to predict a class or value, and then you get out of that. You apply various algorithms to it, and then you pick and choose the algorithm that was able to predict, which means it's like more like I'm an expert. I know what I want, and I want to see whether the system is able to provide me that. If not, I basically fine tune it until it provides me near accurate or accurate results, right? So that's where it says supervised, right? So it's basically learning with the expert, and the person, for example, in this case would be a tester who knows that this is the result I'm expecting from this particular testing. Is it right based on the data set? That's going to be how the system works, right? The unsupervised is basically like if you don't have much of knowledge of output, but you know broadly about to what category it belongs to, right? So here what you do is you determine data patterns, and then it's more like a self-guided learning algorithm, right? And also the most important thing is in the first case you label the data. You say this is what it is. So and then the system would essentially use this information to further process, right? In the second case, it is data is not labeled, right? The third one is the most important thing, which is called the reinforcement learning, right? So the reinforcement learning is something like this. You have a system, you put it in an environment, and depending upon the environment, you see how it behaves, and also you see the results. Say for example, if you see that if it's performing as you expected in a new environment, you basically reward the system. If it doesn't, you basically ding the system, saying that by some mechanism, right? By that, what happens is it is basically the system is learning, and you're doing a bit of guided, or you reinforce, yes, whatever you learned is right. You're on the right track. When it goes to the wrong track, you say no, and then the system basically falls back to other options, and then that's how the learning continues, right? So this is the reinforcement learning is quite a interesting area, and it is gaining a lot of traction because if for whatever reasons, if you want to deploy, for example, let's assume that in a network you want to detect a DDoS attack, right? Let's assume if you have a DDoS signature, DDoS stands for distributed denial of service attack, wherein let's assume you have a website like say Google, you continuously have scripts that found the website to a level that the website is not able to process any more requests, and then it collapses, right? And so how do you do it is essentially you have a bunch of like a bot from various sites across the world, and then it starts pounding it continuously, right? Now what happens is the uniqueness of this is that you have a signature or you have a pattern based on the DDoS attack. If you know the pattern and give a system, the system should be able to say or identify as, for example, let's assume Google gets a request, right? If it gets continuous request, for example, it may suddenly detect that it's a DDoS attack based on certain systems. Let's assume that the system doesn't know, or there is a new type of DDoS attack. How does it know? So in that case, what it needs to do is it's a new environment, and then you need to train the system. That is where what you do is you essentially look at and then simulate, and then there are many other mechanisms like systems like honeypot where you put and then try to improve this reinforcement learning, right? The idea is very simple. The idea is you basically teach the system in more like a, not like a guided fashion. You put the system and then see how it behaves, right? Like for example, let's assume you basically say you allow a kid to walk, right? The kid walks down the lane, and then what you do is you don't tell the kid, hey, don't touch, let's assume there is a fire, right? Let's assume that you are not going to tell the kid, and the kid is basically seeing that's the time when it sees a fire, right? There are two ways to do this. One is when it goes near, you just say, don't touch it, right? And then that's more like you're telling the system. But the other way is you're just waiting, and then the kid tries to touch it, it will get burned. So the next time when it sees the fire, it wouldn't really, how do I put it? It wouldn't really touch it because it got dinged, it got burnt, right? So this is more like reinforcement learning, wherein you put in a system and then basically guide it, and then rather than guiding, you see how the system behaves and then you take it forward. In fact, from then on, it would probably be the system. The kid would essentially be very careful when it sees something similar to that, right? So in fact, that is where there is a famous saying in Tamil. Don't believe whatever that is white as milk, right? Because you never know, it might be some other thing. So these are like the words which our forefathers have mentioned, so that you use that as, this is an example of reinforcement learning, I would say, right? So with that, let me move on to how, so further digging deep. So you see that there are three categories, as I said. So let's assume, let's now see what are the areas or what are the use cases where this learning can be used, right? For example, you want to design a recommender system, right? So in this case, what you do is you go for unsupervised learning. In that, meaning there are mechanisms. For example, as I said, in case of unsupervised learning, it basically groups together, right, and then creates a cluster, right? So a clustering algorithm is used, and then that is where you would essentially use it for recommender system or targeted marketing, right? Let's take a supervised learning, right? So you have say a diagnostic system. A diagnostic system, how do you say it's a diagnostic system? You have a bunch of steps, right? For example, you get a defect, right? The defect, you say, you do an analysis. Now from then on, when you see the defect, you would essentially refer back and say, hey, I know this scenario. Have you checked this, right? And which means that you are classifying it, and then you are concluding that it's a diagnostic system, right? So for example, diagnostics is pretty much relevant to testing, right? And so which means we can use supervised learning. Let's take example of reinforcement learning, right? So a robo navigation. A robo navigation is real time, or wherein you're teaching the robo how to navigate, right? So when it hits, let's assume it starts. What you can say is, if it moves in the right direction, you say, just say +1, +1, +1. It knows that this is the right path. Let's assume it takes a path where there is a blockage or it cannot move further. What you do is like how you help a robot to come out of a maze, right? You basically color it, or you can just say that this is how it is, and then the robot helps the indicators to have the learning reinforced. So that's typically how a reinforced learning look like. So this slide is essentially just to categorize, so you know which algorithm to apply. By the way, the most important thing, let me tell you, is if you want to have a career in machine learning, what you need to do is you need to understand, when you look at a data set, you would need to understand which would be the best algorithm I need to apply for this particular problem domain, or if this is what I need to infer from a data set. So in that case, the first category is essentially, okay, this is my problem domain, this is my data set, this is what algorithm I need to use. So within that algorithm, you run through it, you see the errors, and then you take a course correction on deciding on which algorithm you want to use, and then pick it and basically use it for your own use case, right? So now, so typically when you talk about machine learning, there is a set of steps which you need to follow, right? What is meant by steps is essentially you have bunch of set of data, right? In this set of data, you may not even know which data is relevant and which data is not relevant. If you don't know, then it's going to be very difficult for you to come to a conclusion or use a machine learning algorithm. Let's take an example, right? Let's assume that you are doing a predictive mechanism, right? A predictive mechanism is a system, that particular predictive system essentially needs to guess whether you would be stepping out on that particular day, right? So let's assume that system wants to learn, right? First and foremost, the weekday, right? So which means the weekday can be a parameter, and then the weekday can essentially be as a first data set to say whether you'll move or. Let's assume that you are a working individual, right? You're and not a retired individual. So the data set can essentially say that, okay, the first data set is whether I'm working or not. Second data set is the week of the day, Monday to Friday, and then now the third data is essentially the weather, right? Now let's assume, let's play it for now, how weather plays as a data here, right? So we have three of this data, right? Now you also need to give weightage to them, right? So the weightage you would give for a weekday is higher, right? And then to weekend is lower to make a decision, right? And how much of weightage you would give for weather? It would depend. Let's play it out, right? So let's assume that I want to do a prediction. Okay, now the prediction is, will I step out of the home, right? Assuming that you don't do a work from home, to make it simple, right? So on a Monday, I ask the system, will I step out? So based on the labeling, it would, if it's, let's assume, let's use supervised learning, Monday it would say yes. Saturday it may say no, because it hasn't learned it yet, right? Now we are including weather, and then we say it sees that whether with respect of whether, if the weather is bad or not, I'm going to step out because I need to go to office, right? Now so now for sure you know that the weather does not play a very important factor in this whole discussion, right? Let's move to a weekend, right? We all come on a Saturday, let's ask the system, hey, will I step out? The system would say no, but then you say, hey, the weather seems to be good, I want to go for a drive, right? Now the system understands, oh, if the weather is good, there is a probability that this person goes out, right? So the next time, the next iteration, you basically see that the system is intelligent enough, and then it has taken into consideration the weather, right? Now let's assume the the fourth thing, which is the health, right? So with respect to health, it may play it out. If you are really sick, you may not go, so which means it has higher weightage when compared to others, right? Let's assume a non-relevant data, fifth, which is essentially, let's assume you had a fight with your spouse, right? Do you want to include it in the system? Yes or no is a question. How relevant it is? It may not be relevant depending upon the individual, right? So you see that in the data set, given the data set, you need to understand or find out which data set is relevant to me and what would be the output I am expecting. So that is where if you see that the data, and then sometimes you also need to do a bit of transformation, and that is called the data preparation stage, right? And once you do a data preparation stage, if you want to just use unsupervised, you go to the explore model and it becomes unsupervised learning. If it's, hello? Yeah, if it is supervised learning, then what happens is it starts getting what we call it as features, and it extracts the features, and then what you do is you basically, features are nothing but a tagged information or something relevant to that. You represent it, and then this is called feature extraction. And what you do is you basically input it as a train set or a test set or a production data, depending upon which stage you are in. So let's assume let's take the part of test set. I feed into the test set, I evaluate based on the model, and then see if that particular data is right or not. Now, when I say evaluate, you see that it comes back to the features because, so because you need to give a feedback on whether this particular feature was relevant or not, or the decision, things like that, right? So it's like a loop. Once it is done, what you do is they evaluate. Let's assume it's all good. You basically optimize the model, and then what happens is the model gets archived, right? On the legends, you see that the purple ones are basically the things that we call as algorithms, and then the black ones are essentially the role that any developer who designs a model comes in, and then the green ones are basically the data pipeline, the data as in the data whatever we are talking about, and then the red ones are essentially the decisions, and the dotted blue ones are the actionable result, right? So you would see that the models tend to feed in from optimize, because after optimize you basically archive the model, and you would essentially also archive it. When I say archive, you can use this model for now on for certain systems. Okay? Now you see that it's representation stage, optimization, and evaluation, right? Now if you look at the production stage, the production data, you run through it, and also what you see is you also do a scoring to see how it performs as for different data sets, right? And then finally it becomes a use case, right? Now this is a typical flow, I would say, you apply in your ML exercise. Now moving on to the next topic, the deep learning. This is I just want to touch upon deep learning because deep learning is the current hot topic. So the difference between deep learning, of course, is a subset of machine learning, but another important component in case of supervised learning is what we call as the artificial neural network. So the neural network is itself as a big topic, but just to give a quick overview about it, it basically is like a function. The yellow dots are the hidden layer. We call it as a functions, and you have an input layer and you get an output layer based on the function operates on it, and then you get the output layer. So the functions are essentially evolved over a period of time. There are standard functions which you can use for various use cases. Now what happens is in this particular, for example, the example I gave you, whether I will step out or not, I just gave few parameters. Now if I want to further make the system learn like a brain, let's assume that your kid was smart enough that the kid was watching you all through it, and it can exactly say, "Dad, are you going to go out today?" Because based on that, it can put it. The kid can basically, it can essentially request certain thing. How does it do? So the brain basically observes all of it, and then it further processes. It takes a lot of parameters, and then it tends to come to a conclusion. So how a brain works, that's how a deep learning network is similar to that of a brain, which means there are multiple layers, and then you basically take it through this different iteration to come out with the result. For better use of time, I'm not going to talk further. We can probably have a follow-up session on deep learning network, neural network. But just to sum it up, deep learning is basically it's a type of supervised learning. And another important thing is a simple neural network. When there is a huge amount of data, the performance goes down. Whereas in case of deep learning neural network, it can basically get improved over even if there is a volume of data. Next, areas of application relevant to testing, right? Test case generation, right? How can I do test case generation? Was the request? Okay. So test case generation can be done. Basically, what you can do is if you can extract this information from that of your functional spec or your design doc, then the system itself can do a test case generation, and then you can basically train it so that you give a standard formatted functional spec or design doc, it can basically extract it. Actually, the UI testing is the most well-known. There are a lot of tools that are available for UI testing. I just showed some of the products that are commercially available. So because image recognition is a well-established thing, so they usually use the image recognition algorithms to do UI testing. Next, log analysis. As we speak, there are so many startups and companies that use log analysis as a mechanism to arrive at consensus or do analytics. For example, there is an open source tool called ELK, which stands for Elastic Search Log Cache and Kibana. So it's a well-known tool wherein you feed in the log, it can basically provide you insights into how the system is. And there are ML extensions to ELK which are available, which can essentially tell how the system behaves based on scenarios, right? This can be used for testing, right? Next, traceability. There are traceability infrastructures or framework like open tracing, which essentially helps you to trace a particular call. For example, in a microservice architecture, when there are like bunch of microservices, it's very difficult to debug and decide on which particular module was the failure. So in that case, you need to do a bit of tracing so that you exactly know which module was misbehaving or was a bottleneck. So there was a spec called open tracing, and there are open tracing extensions that are available for that. Then you can do a root cause analysis based on the data, whatever you got, be it in terms of bugs. You can correlate between bugs and then that of the deployment scenarios, be it configuration. You can also compose policy, or you can also compose data set to do a bit of extensive testing. From this, basically, you can arrive at data sets based on the past data. The next thing is defect analytics. You can also do a bit of analysis around defects. So these are some of the areas of application. Now moving on, I also wanted to touch upon, even though machine learning and deep learning are gaining traction, there are other trends that are coming in. So the current trends is essentially ML pipeline. What is meant by ML pipeline is like you may have a pipeline of activity to be done. So in that case, for example, let's assume the testing itself is in different phases, right? Not the same algorithms will be used for the testing phases. There would be different algorithms, there will be different techniques, which means you need to have a pipeline created. So in that case, you need to have data also be transformed from one phase to another phase, right? So there are ML pipelines that's a current trend where people already use these ML pipelines and then use it. Yeah, of course, reinforcement learning that I touched upon is a very hot topic because many people feel benefits for new areas where they don't have a supervisor or a data set or a trained data set or a label data set available. Then another one is called the general adversarial network, which is a very, very interesting area, wherein what they do is essentially to, if you are, okay, the most important thing, by the way, is data set. Many of the machine learning algorithms, they become effective as and when, as they process more data, which means the richer your data set is, the better the performance would be. So let's assume that you don't have much of data. How do you do it? So GAN essentially what it tries to do is it tries to basically create two types of neural networks. One is your real model, and the other model is essentially more like how do I put it? It is a test scenario, or it can basically try to simulate data and then see how the real network work, right? What is, it's actually, by the way, it's a type of unsupervised learning, and they basically create two competing neural networks. One is, as I said, for the data generation, where it can create fake data that looks exactly similar to that of real data. And then the second network is essentially the one that discriminates or processes the data, right? So they basically help you to train as well as also to put in scenarios like cyber detection or scenarios what I was explaining, where you want to detect attacks on your network, things like that, or attack fraud thing. So you use GAN. Then the emerging trends for capsule network. Capsule network is essentially a new model wherein, for example, the deep neural networks, they have failures because they treat in a system, they treat each of the system to be individual components, right? They don't have the capability to look in a sum. For example, let's assume you have a facial recognition system, right? So you look at the system and then it can detect if you're straight to the face. If you turn it, it may not be able to detect because it hasn't analyzed all the directions of your face, right? But a capsule network has the ability to interpret or even know how the other side would look like. It also learns, by the way. It doesn't do it by itself, but it learns and then it takes the system in total, right? So that's called capsule network, wherein it's again a type of deep neural network, where it is similar to that of our brain, right? When you look at your friend, you tend to be, you would be able to exactly identify him even if he's far, or if you have met him, let's assume that you're meeting your friend after 5 years, you would be able to still be able to recognize it because our brain in a way works similar to that of a capsule network, right? So that is where this is gaining a lot of popularity since very early stage. Then another thing is actually reinforcement learning is, there is one of that's called deep reinforcement learning, wherein this is more like for gaming strategies. For example, you would have heard of a famous thing called AlphaGo, which won against a world famous Go player. They were able to do it through such a deep reinforcement learning, wherein in fact what they did was they basically competed itself on basically they created a bunch of systems. They were competing with each other, and that's where they were able to do that. And one other important thing is the human or the person who was playing this game, he made a move thinking that the earlier move that was made by the AlphaGo was not it would definitely fail, but since the system had a deep reinforcement learning, it learned all of it by playing with its clones, and that is where this person lost it because the system had analyzed all possible moves. That's where it happened, right? So then the last one is called the AutoML, which is called automated machine learning, wherein this is basically creating the model without programming, right? I was explaining about you have a programming step to do it, be it data preparation, feature selection, technique selection, training and tuning. Instead of this being done manually, AutoML aims to automate the workflow using deep learning techniques, which means it basically automated the whole ML itself. So that's why it's called AutoML, and Google has open source part of it. Yeah. So those are the things I wanted probably to share with the team. I do see a question: are there any popular AI tools which we can try for defect analysis and defect prediction? I can share it with you because the defect analysis and defect prediction is basically okay. The first one is like defect analysis, right? So it's again a step process. From an AI tool perspective, you have tools, but I haven't come across a. For example, I was mentioning about the tools earlier, right? For example, let me show you that slide. Mabel and Apply tools, they do have certain automation, including defect analysis, as part of their suite. But I need to see whether it is generic or it's specific to certain scenarios. Yeah. So with that, I hope I did not go beyond the allocated time.
No, Prem, you did good.
Thanks. Okay. And I hope I was able to give some information to the team, and I hope your Saturday was spent in a meaningful way.
Yes, it was. Thank you so much. Okay. So we'll wait for a few questions.
Sure.
So one from my end.
Sure.
Um, I would like to know how the results. See, let us. I put the neural network to study the results of the test that I run, and then what models do I engage it to when a new product is developed. So failure. Okay, sorry. There's a lot of echo on the line.
Let me mute.
Hello. Okay, it's much better. So let's say that I let the neural network learn from the failures that I go through. It's a forward learning process, and then I go for a product development of, let's say, version 2. Then how would this learning of the forward learning of the past help me relook at the failure modes that are available in the system in the version 2, and how would it be able to predict what actions or what corrections that I need to do? Is there some work that is done in this area? Prem, are you there?
Hey, I was talking in mute. Sorry.
So,
yeah. So I have seen that neural networks be used for defect prediction, wherein okay. So let's probably play it out, right? So now, what are defects? Defects are nothing but you have a particular feature, and then that particular feature does not behave in the right way as it was defined, right? That is scenario number one. Scenario number two is, of course, there are obvious defects like system crash, so on and so forth, which becomes a bit tricky, right? Let's take the first thing of a feature. You do a feature testing, and then there is a defect, right? Now, so version 1 of the product, you saw that the defect analysis, and you had a bunch of defects, right? So you would definitely have done a root cause analysis, and you would have got the information on what was, I mean, was the defect at a design stage, or was it during the development stage? So if it's at a design stage, it's a much more bigger problem. If it's a development stage, it's a different type of problem, right? Now, one thing is, from a testing perspective, usually what people do is they tend to, I mean, with due respect, they tend to be basically testing the weakest module, because they know for sure that the defects would come from that module, right? Now, what is my goal? There are two things what I wanted to do is, one is the defect analysis, and the other one is the defect prevention, right? Now, the defect analysis can be done in multiple ways, right? One is, first and foremost, what was the issue, right? The issue being, let's assume that there was bunch of parameters that was fed into. I mean, what I'm saying is, the defect was a root cause of the person not handling all the situation, right? That might be one of the, let's play it out, right? So in this case, what can be done is, you can essentially take the defect, and then what can be done is, from an automation perspective, this particular path can be given higher weightage, so that or this okay. So one thing is also, as part of the defect analysis, is when you do an analysis, you tend to be looking at whether the all path testing happened, right? It might be a corner case where the path was not covered. So the defect can be rooted back. For example, I was talking about the tracing tools, right? The tracing tools, one is a deployment scenario, another one is a static scenario, wherein you'd be able to trace statically all of it and then see if it passes through. So now what you can do is, you can generate data, and then you can do a bit of all path tracing, in the sense you don't even need to manually test it, it is automated, right? and then the config parameters are part of your data set, and that is obtained, right? By this, what happens is, number one, I'm able to avoid defect or prevent defect at the earliest stage possible, which means my CI/CD, after the CI/CD is done, the data set gets generated by itself, and then I do all path testing, and when I get it, it is a guaranteed thing saying that all path has been tested. Now coming to feature, I've tested all path, but from a feature perspective, there might be scenarios wherein you would not expect certain things to behave in such a way, right? So then you basically get into a bit of a different analysis. Why is that feature not performing as per my expectation? What is meant? Let's take a real example, right? Let's assume with say 10 with let's assume a database query is there, or a module is there which handles the database, right? You have 100 records. It behaves or it responds in a particular fashion. You have 200 records. It performs in a particular fashion. You have 300 records. It would, let's assume it starts throwing up error, which means there is some issue, and then the system is not able to handle the situation, right? So now these sort of inputs gets into the system, which means that the automated system starts knowing that when I cross a particular threshold limit, the system would behave in a random fashion, number one. Number two, you can also get the data from that of your product manager saying that what is the scale testing you are looking at, right? Which means the system automatically knows this is the scale I need to test the system up to, right? So these are some of the scenarios, but from the algorithm perspective, there are algorithms like what we call as the adaptive resonance neural network, which is actually not supervised learning, but it's a special case of unsupervised learning. And then what they do is they basically use that particular neural network to essentially do defect prevention. I mean, how they do it is essentially they basically I mean have a technique, meaning, as I said, first and foremost is the historical data, which plays a very important role. They take the historical data and then they first train the AR and that particular neural network, and then from then on, what they do is they use a bit of modeling technique in order to predict how the system would behave or whether the system would be defect free. So that is one methodology people use, where they use neural network for that. There are some low-hanging fruits, for example, I mean, not related to defect prevention, but the low-hanging fruit in terms of automated data generation, automated test case generation, then automated scale testing, which are like more like low-hanging fruits, which can easily be used. For example, you can use NLP. There is one of the text classification system in order to parse through some of your documents and then arrive at data set or your test cases. So those are some of the low-hanging fruits I can look at. But from a defect prevention and defect prediction, it's basically via the neural network.
And one just additional question. You talked about all the paths. So isn't that an exponential thing for us to plan for something like this in the routine product development testing cycle?
Well, that's a very important question, right? But in reality, we are working or we are applying ML in a way that all paths get tested by the system. It's not a manual thing, right? Because what you're making the system is you're making the system to detect all paths and then start the testing by itself. The reason I'm telling you is because all paths plays a very important role in terms of microservice architecture. Wherein you have exponential amount of composability happening, and you would need to have such an automated system. That is where I feel that all paths is very important factor. By the way, one other important thing is, in a monolithic, all paths may be exponential. If it's if it's exponential monolithic, imagine in a composable architecture, it would be much more, right?
Yeah, that was the scary part. That was I was trying to refer to.
Yes, yeah, because for sure you can put a limitation saying that these are the scenarios we have, or this is the level of composability I can basically go to, or I can support. Right.
Hey, this is Krishnan. Once again, I have one very basic question. So, typically, as a end user, as a tester, right? The way I would look at it is, as a tester or as a person in the testing team, the testers would go through different levels of experience, starting from requirement stage till the product delivery. Right? There's a lot of learning that happens as the design unfolds, the code unfolds, right? Defects come through, a lot of interaction that happens within the team, right? Now, this learning experience is naturally, as a human, I would think that this learning experience is paramount to a human brain, right? For me, as a distant behavior, as a distant observer of AI, for me it's very difficult to think that an AI algorithms would kind of replace this learning experience from beginning to end. So I can think of brain simulation, I can think of neural networks, algorithms, a lot of things, supervised learning, unsupervised learning, a lot of things you touch the brain. As a test engineer, one of the things I would like to understand is how much is the level of this learning that happens by an automated system using these machine learning algorithms, using this artificial intelligence algorithms to replace the tester. For me, it's very difficult to even think of that these maybe testing bots, you don't call it as testers, call it as testing bots, right? They would learn, they would detect, they would interact with the system, and they would file defects, or they would make sure that the quality is input, whatever. Filing defects or not filing defects is a different thing. Sometimes I even think of, sorry for a long question, but I'm trying to put my perspective here. Sometimes I can even think of these bots may even modify the code in production to rectify a problem which is unforeseen, something like that, right? So what is your perspective, Prem, here in terms of the automated machine learning, artificial intelligence testers doing this job?
Okay, so if I let me probably repeat the question. So
sorry,
that, yeah. So you had, I mean, in your question there are multiple questions, right? So let me probably try to get that right. So number one is, in terms of efficiency, how do you think the automated bot would perform? One question, right? The second question is, there is a bit of our intelligence at play when we do a testing, right? Is what you are, I mean, you are also alluding to that fact, right? The third one is, what would be the extreme level of test level? What would be the extreme level this particular automation can go to, right? Is that right?
That's perfect. Go ahead.
Okay. Yeah. So first and foremost, there is a difference between just a pure automation versus intelligent testing, right? The difference is, an automated testing is nothing but, I know that these are the way to invoke the software. I would essentially start my automated script, be it UI testing or be it any other non-UI testing, and then what I do is I essentially ensure that I just run it so that I can run my regression on a continuous basis, right? So again, the automated testing is basically being written by the individual based on inference, which would have, the input essentially would be the how the feature has to behave, how he has manually tested, so on and so forth, right? Now, in most of the cases, what happens is the observability of the environment would essentially be minimal. When I say minimal, even when a person goes and raises a defect, the developer, in most of the cases, what he tends to do is he tends to say, hey, did you test based on the recommended scenario, right? So then there is a big dialogue that goes on between the tester and developer, and then the developer mostly tries to sort of override it, which means there is a bit of I would say constraint that is put on the tester. I'm talking about from a practical scenario, right? So what happens is the tester in a way puts the test cases or even the automation to the level of how much the functional spec or how much the product manager needs, right? Point number one, right? Point number two is, let's assume even he's super duper how to say concerned about the product, so he goes and extensively does it, right? Now in both the scenarios, what happens is we tend to test the product as a black box, right? We don't have insights into, also there is a general recommendation, right, that we don't want to really look into it because we are going to test it as an end user, so which means the end user is not going to look into it, right? Now, is it right or not is the first question. Let's assume that you feel that's wrong, right? Let's assume he is allowed to test it like a white box, right, with modifying the parameters, so on and so forth, right? But the issue here is, again, he doesn't have insights because the product gets developed from multiple teams and then he does not really know how things are, right? But let's assume that he's given a blueprint. A blueprint as in he completely knows how the method call happens. He looks at he puts a parameter, it exactly shows him this is the path it has to take, whereas this is the path it has not taken, so on and so forth. He is going to be much more intelligent when he gets insights into it, right? Now, again, now the bot, whatever I'm developing, if it's going to make it as a black box, it would continue to be like human. But one thing what I can do is I can essentially make the system to develop parameters that are going to be falling outside, which means my test case parameters are, the test data is going to be extensible, number one. Number two, if at all if I have the freedom, I can essentially make the system to get a blueprint of the whole call to whatever I explained, and then feed it so that it exactly knows this is how the system performs, and it can basically diagnose it in the first look, right? Now the third thing is, to what level can automation happen is the third scenario. For that, I would essentially say that we need to be creating a lot of production-like data, right? When I say production-like data, it is all through simulators how I would essentially get a production-like data. So that is where I feel that a bit of intelligence would come in, wherein I can essentially try to create user-like scenarios and then make it test like that. What is meant by that is, let's assume that you are allowed to log in, meaning what I'm saying is, you basically have a software and you have it's a multi-user system, and then in a typical case the human tester would essentially log in as twice or thrice. Even the automated system, they could log in as n number of times. Even the operation it would perform would essentially be limited to that what is. Whereas if you get intelligence, it can essentially exponentially test it from different scenarios, meaning it can be 100 users that can simultaneously log in. It can basically create different data sets. It can even you can tune it in a way. So what I'm trying to say is, it can essentially be like it can play a devil's advocate the moment it learns the system and the moment it knows how the system performs. right? That is where I see that there is a lot of possibility coming. Sorry, it's a long answer, but I hope it answered.
I think it gives the right perspective. Thanks.
Okay, so this is Kurmi. We are at 11:24 and need to do a just time check. So can we take one last question? Okay, looks like it's not there. Sorry about that. So next agenda in today's conference was supposed to be how to grow a community to a successful destination. So Prem, you were planning to talk about that experience as well. So can we take that now?
Sure. So this
Great,
is based
thank you.
Yeah, thanks. So this is based on my past experience. So when during 2010-11, when cloud computing was just beginning to start, what I did was I basically did what we call as cloud camp. So a cloud camp is actually interesting. It's called unconference, right? The idea here is what we do is we tend to the unconferences audience comes without any preset agenda. People come there, and then we basically, let's assume in cloud computing, we tend to ask, hey, what are the themes you would like to listen about? Then what we tend to ask is we also tend to ask, hey, what are the one is the theme, the other one is we also tend to start asking people questions about the theme, right? We tend to write this particular question in a we collect in a standard format, like we ask for 10 to 12 questions, and then we tend to ask the attendees to give a priority. Once that is done, what happens is we basically, in fact, you essentially see that when you open up, there will be a lot of people who would be interested, and then what we tend to is we tend to create a informal discussion between them, and then we tend to arrive at some people who are quite knowledgeable about the topic. They become what we call as the unpanel. In the unpanel, what they tend to do is they meet, we pick 4 of them, they sit in a panel discussion, they tend to answer or discuss upon this question. By this, what happens is there is a lot of knowledge sharing that starts happening naturally. People lose their inhibition. They tend to be more participative. So I grew the community from somewhere around 100 to that of somewhere around, last when I checked, it was around 4,000. So how it grew was we also basically this is the unconference happens every now and then, and the other follow-up is every month. What we tend to do is we tend to sort of meet. By the way, there are no pressure. It's basically whoever can walk in. We tend to have topics, and what we tend to do is we tend to have like a informal discussion similar to that of what we are doing, and people come there and then they continue the discussion whatever they had during the unpanel, or we invite few industry folks to do that. Probably, I don't know, because cloud was starting to happen, the community grew up, or because we are trying to do the same even today now in Bay Area for topics like serverless, for topics like microservice architecture, for all the emerging trends. But in a nutshell, this type of unconferencing helps grow the community a lot. So that is what I wanted to probably share with, and also I can provide you guidance on how to run an conference in a successful way.
Sure, thank you so much. So that was a great idea that we probably can leverage from your experience and take it forward. I will definitely reach out to you on this, on how to facilitate that.
Right, and another important thing is we also operate to freshers, so there is no restriction. It has to be industry folks only. So by that, what happens is freshers today gain a lot, and then they also volunteer to talk about it because it becomes a knowledge sharing, or they basically improve their communication skills via this platform. Yeah.
Okay.
Cool. Okay.
Any questions on that from the members of the organizers or community who wants to volunteer to drive the next few sessions? Okay. Any other questions for Prem? Okay. Looks like we don't have. There's again the echo is back. Hello. Okay, thank you. So thank you so much, Prem, for this enlightening Saturday morning idea sharing session. Personally, I have definitely learned a lot, and I would like to continue my research into this area and my learning, and I hope the same feeling would be generated in the other participants who listen to you. This is a hot topic. And a lot of, like Prem said, a lot of investment is getting done in many organizations, and I can talk about SAP. SAP being one of the big software development organizations in the world, it is also spending a lot of money in machine learning and artificial intelligence into their product development as well as product testing. So great, thank you so much once again, Prem, and I'm happy to have you as a part of the group sharing this knowledge, speaking on behalf of the others as well.
Yeah, thanks for the opportunity. And one last comment is, I think if someone someone has entrepreneurial bug, or if you have that drive, probably this is best time to probably get into or look at start doing a startup around this area. Definitely, I believe you will get funded, and yeah.
Thank you. That's a great idea. Yeah. Okay. So with this, we come to an end of our webinar number 7, and Krishnan, who was not willing to be part because he had other commitments, we have him throughout the session. Krishnan, any thoughts before we part?
No, I think it was great. I think thanks to Prem for accepting to do the session. It was actually great learning. So thank you very much. I think with that we are done with the conference. We'll see what next to do, whether it will be a webinar or whether it's a conference. I'll keep you updated. And we'll continue to do in a similar form. We'll take new topics going forward. We'll also have reconstitute the panel discussion. All that will happen. So I would say with that, great job for me. A lot of the anchoring has been awesome. So excellent. So
thank you.
Thank you. Have a good
Krishnan.
Saturday. Yeah, and a great weekend. See you next forum. Thank you, Prem.
And the last few academic notes are. The recording will be available in the Yahoo channel. Yahoo channel we have, and also from the YouTube channel, and also the mails in the that comes to us. And also stay tuned for the next webinar. Supposed to be scheduled for the first Saturday of September. So we'll keep you posted on that. And with this, thank you so much, and have a great weekend. I'm signing off.